Okay, so I'm at home now taping this second part. So if you hear a barking dog or clicking toenails on the floor or any number of weird stuff happening, please know that I'm at home, and this is what happens when Miss Mason does these recordings at home. All right, we are on assessment 2, number 11. We are selecting the letter that best answers the question. On these, you may use a calculator. So first question, number 11. Which two shapes have a ratio of 4 to 3? So we're looking for a shape that is 4 being compared to a shape that is 3. So counting 1, 2, 3, there are 4 stars. 1, 2, 3 circles. 1, 2, 3, 4 squares. 1, 2, 3, 4 triangles. So we have multiple choices that we can choose. We have 4 of many things. First one is, it says triangles to squares. The triangles have to be 4, the squares have to be 3. So how many triangles were there? 1, 2, 3. There are 4 triangles. Are there 3 squares? We look, and there's a 4th square. So that is not a possibility. Circle, stars to circles. So there has to be 4 stars. Are there 4 stars? Yes, there is. Are there 3 circles? 1, 2, 3 circles. So your correct choice for a ratio of 4 to 3 would be stars to circles. Check the squares. There are 4 squares, but there are also 4 stars, so that doesn't work. Circles, there are 1, 2, 3 circles, and there are 1, 2, 3, 4 triangles, so that does not work. All right, always remembering, you must look in the direction in which it is written. 4, 2, 3, so the first word has to be 4, and the second one has to be 3. Must follow that direction. Number 12, which letter on the number line represents an integer that is greater than -2 and less than 1? So here is -2, here is 1. Which integer falls between that? The letter, oh, this is duplicated. A, B, C. Am I reading this weird? A, B, A. Oh, A is A. B is B. C is C. And D is D. And duh. Which one falls between those two? It is B. Okay, it's late. Maybe I shouldn't have done this tonight. All right, 13. Select all numbers that are less than -7. So if we're looking on the number line, less than -7 goes to the left, keeping in mind that everything to the left of that is less than -7. Would -10 be to the left of that? Yes, it would. Is -15? Yes, it is. Is -6? No, -6 would be over here, so it is not. -20? Yes, it is. 0? No, 0 would be down here. -1 would be down here. So no and no. So our 3 possible answers are U, X, and Y. U, X, and Y for an answer choice of D. On these type of questions, remember you've got to answer them all. Don't get one answer and then stop at that one answer. Make sure you proceed until you have everything that fulfills that question. You have to make sure that you have all the items, that fulfill that question. You can't stop partway through. All right, number 14. Which of the following equations are not true? Those 2 lines, these 2 lines on either side of a number like that, means absolute value. You are responsible to knowing that. Absolute value, which is the distance a number is from 0. And the big thing about absolute value is the fact that it is always positive. So looking at absolute value, the absolute value of -4 is equal to 4. That is yes. But if you look at your question, you are looking for which ones are not true. So this is a true statement, so that is not the answer to that. The absolute value of -2 equals 2. Yes, it does. So that is not a not true statement. It is true. The absolute value of 4 equals -4. Well, we said in our definition that absolute value has to always be positive. So this is a not true statement. Therefore, it is your answer choice. Number 15, which expression is modeled below? You have to look again. Remember your horizontals. Whoopsies, horizontals, labeled that wrong, and your verticals. Remember labeling these, your horizontals and your verticals. Remembering the total number of your horizontals is your denominator. So we have 3 horizontals and we have 5 verticals. And then to find our numerators, we count shaded pieces. So here's a horizontal shaded left to right, another horizontal shaded left to right. Is there a third one? No. So that's 2/3. Then we look at our verticals, shaded top to bottom. 1 shaded top to bottom, 2 shaded top to bottom. Any others? Nope. So then we have 2/5. So our multiplication problem is 2/3 times 2/5. It can be written either way. Here we see 2/5 times 2/3, but it can be written either way due to the fact that it is a multiplication problem. Next we have which equation is modeled by the picture. We did this with boxes and then we cut them. This is a hole, this is a hole, this is a hole. How many holes do we have? 3. 3 holes, 3 holes, 3 holes, 3 holes. Now we look inside here and we see that they're cut into smaller pieces. And how many smaller pieces are they cut into? I see 1, I see 2. I see 1, I see 2. I see 1, I see 2. So when we're looking at our 3 holes, we're looking to see how many pieces are they cut into and how many pieces are they cut into. They're cut into 2s. So 3 divided by 2s. Do you remember doing this with the boxes? We have boxes that look like this. So then we said 2, and then we cut them into little boxes underneath. Remember we did this? So then it was divided by what? 1/3. Remember 1 would be shaded, and then it would say 1/3. These aren't shaded. I think it's halves. This is divided by a half. This is a half, 1/2, and 1/2, and 1/2, and 1/2. It's this one. So what you're looking for is the number of halves. 1, 2, 3, 4, 5, and 6. Ours looks like this though, where you have a full box and then you have little arrows that came down and then they cut them into smaller pieces. Or if they group them into 2s, then this was divided by 2/3. Remember that? And then we don't really divide fractions. We multiply by reciprocals, etc., etc. All right, number 17. Bobby put his dog in a square-shaped dog pen. If one side of the pen was 12 feet long, how much space did Bobby's dog have to run? Well, you need to know if you're finding area perimeter. Does Bobby's dog only run around the outside edge of his pen? Or is Bobby's dog able to run all in here on his pen? Well, if that's the case, if he's all in here, which he is, then you are finding area. You are covering, you are carpeting. You are not putting a fence around, you are carpeting. So area equals length times width. In this case, we have to use our knowledge of squares. If a square's side is 12, then its other side is also 12. And 12 times 12 gives us an area of 144 feet squared, or square feet, whichever way. Well, you have to know that when they write it in words, it's square feet. All right, number 18. At Travis's birthday party, 5/8 of his birthday cake was eaten. The next day, Travis ate 1/2 of the remaining cake. What fraction of the cake did he eat the next day? All right, the first thing we need to realize is that we started with a whole cake, yes? And at Travis's, if you start with a whole cake and you're dealing with eighths, it says that 5/8 of his cake was eaten. We're starting with a whole cake, and a whole cake has to be a total of 8/8 to make one whole. So then 5/8 of his cake was eaten. So if you take 8/8 and you subtract 5/8, you should come up with a fraction of 3/8. When the party was over, 3/8 of his cake still remained. Because they ate 5/8 of it. You started, this whole cake is 8/8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. They ate 5 of them. 1, 2, 3, 4, 5. That left you with 1, 2, 3/8 left. Then it says the next day, Travis ate half of the remaining cake. 1/2 of tells us to multiply. Remaining cake, it's no longer one cake. It's not 5/8 of a cake, because that's not what's left. That's what they ate. What was left was 3/8 of a cake. So how much cake did he eat the next day? Well, multiplying fractions ain't no problem. Top times top, bottom times bottom. He ate 3/16 of cake the next day. This one is a thought process one. You have to start with a whole, and you have to make sure that your fractions are what you're dealing with. If he ate 5/8 of a cake, then a whole cake was 8/8. My daughter left ice cream here, half-baked Ben & Jerry's. I'm going to eat 5/8 of that in just a few minutes. It's getting soft, so I can poke it out with a spoon. I'm going to tell you, I have a whole, it's not whole, she ate some of it. I have that much of ice cream, and I'm going to eat 1/2 of it. How much is left? Just kidding. Hey, Addie. My grandpup just came and stuck his nose against my arm. I don't know if y'all can see him in camera or not. Anyway, all right, I digress. Anyhow, 19. Emily is baking chocolate cupcakes. Each batch of cupcakes requires 2/3 cups of cocoa. Each batch. If Emily has 3 1/4 cups of cocoa, how many batches of cupcakes will she be able to make? So she has 3 1/4 cups. And if we take that 3 1/4 cups, 1, 2, 3, and then she has a 1/4, this little teeny tiny edge, a 1/4 of a cup. And we need to see how many 2/3 cups can you get out of that. So she's dividing it by 2/3 cups. She takes the 3 1/4 cups and she scoops out 2 2/3. And she scoops out another 2/3. How many 2/3? So you're dividing that 3 1/4 into thirds. It's hard to do with a fourth. Anyhow, mathematically, we don't divide. We multiply by reciprocals, but we can't multiply by reciprocals unless they are improper fractions. Sorry, needed a drink. 3 times 4 is 12, plus 1 is 13. 13/4 divided by 2/3. Now we have fractions, but we don't divide fractions. We multiply by the reciprocal using the trick K, F, C. Keeping, flipping, changing. That sounds familiar. Keeping, flipping, changing, keeping, 13/4. Flipping, 3/2. Changing, divide to multiply. Multiplying fractions ain't no problem. Top times top, bottom times bottom. 3 times 13, 39. 4 times 2 is 8. Can I leave 39/8 as my answer? No. I must change it into a mixed number. How many 8s are in 39 without going over? Well, I know there are 4, which gets me as close as 32. Then I'm left with 39 to 32, which is 7. And I bring over my denominator of 8. So she has 4. How many batches of cupcakes? This is not cups. I'm wrong. That's batches. She can make 4 7/8 batches of cupcakes with her 3 1/4 cups of flour. All right? Number 20. Mr. Scott went on vacation to Philadelphia, PA. On his trip, he bought 20.5 gallons of gas in Richmond, Virginia for $3.78 per gallon. He then stopped in Baltimore, Maryland, where he bought 19.75 gallons of gas for $4.02 per gallon. How much total money did he spend on gas? Pretty easy one. Figuring up some math. If he's paid $378 and he bought 20.5 gallons of gas, multiplying it. And by the way, on this part, it says you can use a calculator, so no brainers on these. He bought 19.75 gallons of gas for $4.02. Not lining up decimals, remember. You are lining up digits. 5 and 8, 40, carrier 4, 35 and 4 is 39, and 15 and 3 is 18. Placeholder 0, 0, 0, and 0 for each of those. 2 placeholders, 2 and 8 is 16, and 1 is 15, and 1 is 7. 0, 9, adding them together. So on his first leg, 77 point, because we have 1, 2, 3 decimal places, 1, 2, 3. So on his first leg, he bought $77.49 worth of gas. But then he had to buy more. 0 and 1 and 15 and 19 and 3. Placeholder, 1, 2, 3, 4 zeros if you multiply each piece by 0. 2 placeholders, 4 and 5 is 20, carrying a 2, 4 and 7, 28, and 2 is 30. 4 and 9 is 36, and 3 is 39. 4 and 1 is 4, and 3 is 7. Adding our columns, 9, 3, 9, 7. Counting the original problem to look for decimal positions, 1, 2, 3, 4. 1, 2, 3, and 4. 79, if we round here, that becomes 40 cents. If we don't, 39. Should be close enough to get an answer. So we have 77.49, which is not our answer, but it's a choice. And we have 79.40, which is not our answer, but it's a choice. Welcome to the world of out there, ladies and gentlemen. They're going to try and trip you up, so you got to make sure you know what the question is asking. How much total money did he spend on gas? Not for Richmond to PA, and not from PA to Baltimore, Maryland, the whole trip. 9, 8.6, 15, $156.89 on gas. Entire total amount. All right, that is assessment 1 and 2. There'll be 2 separate videos. Make sure you're going through them. Anything you've missed, make sure you get on there and look at it, find them. I'm gonna eat my ice cream, then I'm gonna do the other package. Bye.